Well, hello there guys, here Mr. G with another video for the grade 10 related to waves. Last time we spoke about some concept of a transverse wave. We obviously learned what is a transverse wave, but we also learned some concepts, some definition like crest, trough, amplitude. We learn about a position of equilibrium or equilibrium position, and we learn those things. Okay, so here is the last video basically. Now this time we're going to learn about some very important new definition like wavelengths, points in phase, period, frequency, and speed of the wave. It's a little bit more, but the video won't be that long, I promise you. So let's start by wavelength. Okay, so let's start with the first definition, which is wavelength. Wavelength is the distance between two consecutive crests or two consecutive troughs. Remember, the crests are on top and the troughs are at the bottom. Okay, so any two consecutive crest will be, for instance, this one and this one. This will be divided by something we call wavelength. This distance here is wavelength. Those are consecutive crests. Okay, so that is wavelength. That is one wavelength, or two consecutive troughs. So this one here is also one wavelength. That is another wavelength. All right, now that is important. Any two consecutive points, or any two consecutive crests, or any two consecutive troughs. Now, important, the symbol for wavelength is going to be the Greek letter lambda. This here is the symbol for wavelength. Okay, is lambda, and because it's a distance, in actual fact, this will be, the unit will be the meters. That is the SI unit for wavelength. However, in the class, in the school, we use centimeters, we use millimeters sometimes. Okay, depend the question. But if you're going to do calculation, then it must be in meters. So this is the wavelength, is the distance between any two consecutive points that are, we're going to go to that definition now, any two consecutive crests or any two consecutive trough. For example, this one represents one wavelength. Okay, so I hope this one is clear. It is very easy. It's the distance between any two consecutive crests or any two consecutive trough. Now, so now that we know what is a wavelength, let's define points that are in phase. Now, points in phase are points that have the same motion at the same time. That is important. Same motion at the same time within the transverse wave. So, for instance, one cannot be moving up and the other point cannot be moving down. So, both points are moving at the same time, either up or down. But the most important part is that they are separated by a whole number of multiple wavelengths. So a whole number means they are separated by either 1, 2, 3, 400 wavelengths. Okay, that is important to know. So it's not necessarily going to be two crests or two troughs, but a whole number for one wave separated any 2 points. So let's see this one, how it look like. So for example, in this wave, 2 points that are separated to one complete wavelength is this one here, but this one is also part of those. So we can say that this one is one wavelength, for example, and this one is two wavelengths, another wavelength. So these 2 points here are to be in phase because they have the same motion at the same time and they are separated by one wavelength. But it's not necessarily have to be two crests. For example, this point here and this point here is also separated by one wavelength. So we say that these 2 points, this one is one wavelength there. Or for example, this point and this point is separated by one wavelength. So those 2 points are in phase because they also have the same motion at the same time. So those are, for example, points that are in phase. It's a very important concept. And then from here, we're going to get a new definition for wavelength, which is the most complete one. Wavelength is the distance between two consecutive points that are in phase, and that definition we're going to write it right now. So we can now say that wavelength is the distance between any two consecutive points that are in phase. So this is now the more general definition for wavelength. and also the one that we are going to be using more. So far we already know what is points in phase, we know what is wavelength. We have two definitions for wavelength. You can use either one, but the most correct, the more general one is this one, which is any two consecutive points that are in phase. We learned that wavelength is distance, and therefore the SI unit is the meters. It is right there. Okay, so I hope so far we are winning. We are getting there. And therefore we are going now to the other two definitions of the lesson, which are a period and a frequency. So let's talk about period and frequency. This is quite easy definition, guys. Now, what is period? Period is the time, and this is important. We're talking about time. The time taken for one complete wave, only for one wave. So the time of one wavelength, how far one point move one wavelength. Okay, that is what we're talking about period. The symbol for period is going to be capital T, but the actual letter is a Greek letter tau. However, if you substitute T is also fine. That is a period, is the symbol. The SI unit is the second. The SI unit is the second because it's the measure of time. So the SI unit is second. However, sometimes you can see it in milliseconds or in minutes or so on. But the SI unit is the second. So please know that it is important. Okay, so this is about period, and we will see the formula right now. But before that, let's define frequency, which is the next term. And what is frequency? Frequency is the number of waves that pass a specific point in 1 second. So be careful, this is different things that can get you confused. Period is the time taken for one complete wave, but frequency is the number of waves that pass in a point in 1 second, only 1 second. The symbol for frequency is a small f. Sometimes you can use another symbol, but we are going to focus on symbol f. That is the symbol for frequency. And the SI unit for frequency is going to be the hertz. The hertz is the SI unit for frequency there. Okay, this is the SI unit for frequency. And now we can see the formula. Now, frequency is going to be equal to the inverse of the period. This is the formula for frequency, and from here we can see that period is going to be equal to by 1 divided by frequency. Is quite simple, guys. It's very simple formula, but very important formula you're going to be using all the time. So you're going to do a lot of calculation where you have to use this simple little formula here. So far we go to recall quickly. We spoke about wavelength, we spoke about points in phase. Now we're speaking about periods and frequency, and we're going to be speaking about the last concept, which is speed of the wave. So for the last definition we're going to be speaking is wave speed, and this is the distance wave travel per unit time. How far one wave travels in how long. That is what we're speaking about. The symbol for wave speed could be a V, but we are going to write speed. And sometimes they use the symbol B, or most of the time they use the symbol V. In South Africa, sometimes they use the word speed. This is equal to distance, which the capital D, divided by the time taken. Okay, so this is the formula for calculating the speed of the wave. Note, this one here is distance, that one there is distance, and the unit for distance is meter. This one at the bottom here is time. This one is time. And the unit for time is the second. So we have the meters divided by second, and therefore that would be the unit for speed. This one is the unit for speed, which is meters per second, and can also be written as meters per second. This one is the accepted one here in the region we are working with right now. So that is the unit for speed. So speed is equal to distance divided by time, but it can also be rearranged. For example, we can say that speed is also going to be equal to, if the distance is wavelength, the time for one wavelength will be the period, and this is also a formula that we can use for speed, wavelength divided by period. Or if we rearrange, which I am not going to do right now here, and we substitute the formula for period, which is frequency, we have that speed is equal to the frequency multiplied by wavelength. And all these are three formulas we can use to calculate the distance. So we have here one with wavelength, we have here one with wavelength and frequency, and we have one here with distance and time. So please, you can use either of the three formulas. And this video is almost done. We have now all the concepts that you need in terms of transverse wave. I think this is everything that you have done at school. Please, if there's something that you need, you can always let me know. And just to finish, let's look at one very small example so you know how to use this formula, and that will be the end of the video. So let's look at this example. When a particular string is vibrating at the frequency of 10 Hz, and they're giving you the frequency here, frequency of 10 Hz, a transverse wave of wavelength 0.25 meters is produced to determine the speed of the wave. So as usual, we're going to always follow this approach. We're going to write the data of what we have. Now here we have, first of all, the frequency is given to us, it is 10 Hertz. We have the wavelength, which is equal to 0.25 meters, and we are looking for speed, that will be question mark. Now, according to the data you have, you go to the formula for speed, and you can see that the most suitable to be used is this one here, because we in actual fact have everything. So speed of the wave is equal to frequency multiplied by wavelength. You always write the formula first, always, and then you are going to substitute. So you're going to change the letters for the numbers. Frequency is equal to 10, and the wavelength is going to be 0.25 there. So when you, this is a 5, when you calculate that one, the speed of the wave is going to be 2.5 meters per second. This is the speed of the wave. In other words, this wave will travel 2.5 meters in 1 second. And guys, this is all for now. Next time we're going to be doing a question on this work on transverse wave, which will be practicing everything. But thank you for watching. You, as usual, you can ask questions, you can suggest, thumb up, subscribe for the channel for the other videos that I will be making. Thank you for everything, and I'll see you next time. Mr. G here.